somebody still wake up. Anyone? Can anyone answer why there's no option here? Standard SNA for IPv6. Just now I say the syntax almost the same. They are not exactly. For IPv4 there's option standard or extended if you can still remember. But for the IPv6 there is no option of standard or extended because by default there is no standard IPv6 ACL. And by default all are considered extended ACL, right? That's why when you type this, okay, the syntax will be extended. Yeah, the syntax will be extended. Sorry, the syntax, all the syntax will be extended. Okay, that's why there's no need option to choose standard or extended because there's no standard ACL for IPv6. Okay, these are examples, right? There are so many protocol in IPv6. For example, network discovery, because they can detect IPv4. They can detect, okay, who's the next, who's the router, who's the next router. Okay, what is my prefix address? If we already configure this router interface with IPv6, okay, this host automatically they will get the IPv6 address. Okay. So in theory, you can have thousands of addresses, IPv6 address. By default, if you enable IPv6, then you will notice that you already have several IP addresses. Okay? If you are participate in what I call IPv6, already you have one of the address. I mean, all host address. I can't remember now. 201 something. All host IPv6 address. Okay? So all PC, all the interface will have this some address, 201 something. And then for this router, okay, they have all hosts. Same. Also, they have what I call all IPv6 router address. So minimum they have 2, 1, 2 address, all hosts, and then all IPv6 router. Once we enable this interface with IPv6, right? So we have this and this. Okay, so there's protocol, they call it neighbor discovery association, solicited, all related to finding the neighbors, finding the prefix for the host. So you need to allow some of this protocol to come into your network. Okay, firewall technology, securing network with firewall. The term was adapted. You can read. Okay, what's the meaning firewall? This term from the firewall of the what I call building, inside the building. You notice the windows, the door, firewall door. So if there is a fire happen, and then the firewall door at least will stand for few, maybe if not hours, then few longer, because the fire cannot go. Cannot go through that windows, right? So this term applied to the computer network. Also, they call it firewall, prevent undesired traffic from entering the prescribed area within a network. So all firewall should at least resistant to attack, right? Should resistant to attack. If you put firewall but it's not resistant, I think no point if we put our firewall. Okay, the aim is to have the resistant to attack. That's the reason why we want to have the firewall. Okay? And then the only transit point between network, because all traffic flow through the firewall. It has to be like this. If you put the firewall here, but then the traffic go through somewhere else, there's no point. You are not, because the firewall is the inline. Yeah, all the packet must go through the firewall. Yeah. If you have firewall, there's some other entry, then your network is not fully protected. And then the firewall is the one that will enforce your access policy, your control. You will control the policy. You say that, okay, that I want to allow this access from that network. I want to deny that particular network from entering your your network. All the policy that you implement basically will be enforced inside your firewall. Okay, there's some benefit and limitation of firewall. Okay, allow traffic for any external address to the web server. For example, you can allow this, you can allow this kind of traffic. Okay, we can deny all this, whatever you want to deny. Right? You can put them. This is related to policy as well. Just now. These are example of firewall setting. What are benefit and limitation of firewall? Okay, maybe you can refer to the curriculum after this, right? Types of firewall. Okay, we have packet filtering firewall. Packet filtering firewall will protect your layer 3 and layer 4. The one that we see just now, the extended, they are packet filtering firewall. And because you can control, okay, equal to 22. 22 is the port. Okay? You are saying that either you want to permit or deny 22, meaning this is the port number. Port number implement inside the transport layer, right? Okay. Network. Okay, we know this. All must at least network. All whatever firewall, they must at least protect the network. Source address, destination address. These are all network under the network layer. So we have packet filtering firewall. So every single packet that come in will be checked against the firewall rules, source, destination, and also the port numbering. Okay, and then we have the application gateway firewall. This is now I think the newest one. They can understand, okay, what application that you are running. That's why you notice some application you cannot run inside UM. Okay, for example, you are accessing the some website, for example, and then some you are running some application, the what they call torrent. I'm not sure now because I haven't used torrent nowadays. Because it seems that we don't need torrent anymore. You can download things easily nowadays. So these are applications. Basically, they understand up to the application layer. Layer 5, 4, 3, and up to the session. They will establish the session. They will detect the session go and out. Right? And then we have stateful firewall up to layer 5. Similar with the previous one packet, but then now they can detect the session as well. This is the stateful. Later we're going to demonstrate how we can use stateful as well. Right? So monitor the state of connection, whether the connection is an initiation, data transfer, or termination state. So the session, I think you learned this in TCP, there's session packet. So that it will read this, read by the stateful firewall. If you are initiating, for example, we ping from inside, you want to allow the ping to come back to your network. So that is initiation. Somebody from inside, for example, ping, then they come back. If you are accessing the FTP, for example, FTP to the server outside your network, you want to allow the FTP packet to come back. Okay, there's special packet about FTP. Because FTP have 2 ports. They use 2 ports. Later we'll see the example, right? And then we have packet filtering firewall, the advantages of this one, permit denial, okay, whatever, okay, maybe you can read them. We have source, IP, the protocol. This is what we implement just now, extended, if you still remember. We have source, port number, destination port number, and then they can what they call synchronize start packet receipt. So this one maybe you can read more about this one. And stateful firewall, state table. They will create what they call state table. You will configure what they call permit, this one, and then when you configure the stateful firewall, it will create temporary ACL that will allow that session packet to come back. That's why they color this, make it in red. This one. Basically, you are configuring stateful firewall. You don't configure this. There's some keyword that you configure in the stateful firewall, and then when you access whatever is permitted here, for example, there will be a temporary ACL created. They will allow the packet to come back. So this is what we call stateful firewall. You will see this. Actually, if you configure stateful firewall, you can check show SSD. You can see this temporary dynamic. They call it dynamic SS list. They will allow them to come back to your network. stateful firewall benefit and limitation. We have benefit of the stateful, all of them, you can read them. Then we have next generation firewall, the granular identification. You can detect the example just now I mentioned, the application level. What application they are using, they can block or they can permit. What website you are accessing, they can allow or they can permit. And then we can restrict, for example, website. We can protect against internet threat. This is what under what I call next generation firewall. Right? All this, I think, some are similar, right? CBAC, they call it CBAC, content-based access control. Stateful firewall feature added to Cisco prior to version 12.0. Starting from this, they provide form and function traffic filtering. This is traffic filtering. User one initiate session, go through firewall, right? And then return traffic of user one session is permitted. So let's say this is session, the firewall allow this to go pass through. Then the firewall must allow them to come back to your through the firewall. So return traffic is permitted. That's why here it's allowed to come back. So this is a classical firewall, classic firewall or stateful firewall. Okay, how it operates? Okay, you examine inbound ACL. Requests are permitted to leave the network. So allow, for example, we say okay, you already configure allow, and then this iOS, this is iOS. They will compare the packet type to inspect the rules. It be tracked. Track means stateful. Track means stateful. That's why you see they will create dynamic ACL entry that will allow to go back, to come in back inside our network. And then add the information to the state type to try execution, and then add the dynamic entry. Dynamic entry, the example. This one. We created. This is. Then how we configure classic firewall example. You can follow this. Actually, I have this. If the time permit, then I will try to demonstrate after this here. The traditional way of configuring the firewall for stateful firewall. So you are saying that okay, I want to inspect this particular rule you configure that will use SSH. So this the command here, you need to apply this, and then the rest. Okay, you by default you say okay, I want to deny all, deny any to come back to deny any packet. This one you want to stop by default. This is what it says here, and then you apply that inside the interface. We apply them inside the interface. You deny, and then you apply them inside this. So meaning going in. So meaning come back to this one. Okay, you want to deny by default. Deny. Okay, there's when we configure stateful. Okay, this is one way of configuring. I said one way because there are several other ways. Just now we see establish. There is another way of configuring. Okay, one way. This is very old one. Inspect. We use inspect, and then we give name, and then you say you want to inspect SSH, and then SS list we say extended. Okay, you create the SS list, and then we go to the interface. Okay, this is normal. This is what we have learned just now. But then this is the new statement. We want to inspect this rule, which is inspect the SSH. Okay, this simple command, this simple syntax will allow SSH to go out, and then you will allow SSH to come back. Even though we say that we deny all the packet from entering this, by default we deny everything. This is the statement. Deny everything, we deny. But then with this, what I call stateful, whatever packet that allowed to go out, and then it will be allowed to come back to your network. Okay, firewall in network design. Okay, we have inside and outside network. You know that we have firewall. You know that okay, this is your inside network, this is your outside. So you want to protect your inside network from people, from the outside. So basically, normally, okay, we want to allow everything to go out, and then we don't want people to come and access to your network. So this is the basic functionality of firewall. You protect your own network. At the same time, you disallow your inside from the inside access to go to the internet, but you want to protect your network from people, people from the side. You protect them. Okay. Functionality. Okay, there's a concept of firewall nowadays. They call it DMZ as well. We have inside, we have outside, but there is also DMZ. This is where we put all our server. Right? We put all the server because we want people from outside also to be able to access your server. For example, you have web server, or even nowadays we have remote workers. You want them to be able to access the server. Whatever server they implement here, you want them to access. So this is what we call DMZ. So you can create later when you configure ASA, you will play around with this. Yeah, you configure inside, by default this is 100% security. But outside this is 0% security. And then you configure DMZ, this is 50%. Okay, 100% can go to lower, but then lower can go to the sorry, this one is actually for SAA. They can from the outside they can go. So the color green here. So color here. Later, okay. When we come to SA, you will see this clear. Keep this for later chapters. So this one mean okay, you can go, but then from DMZ cannot. This one as well, people from inside they can go outside, but then people from outside they cannot go in. So you can see this. Stop. Right? Stop. This one outside, inside also they can go. Right? Go. Zone base. Okay, we'll configure. I will demonstrate configuring the zone base later. This is now an easier way of configuring the iOS. Maybe this is our iOS. This is not ASA. ASA is, as I said, dedicated. But now we are using our current router, but we want to implement firewall. So one of the new method is to use what we call zone base. Okay. Layer defense, whenever network core, you know that we must have this. We must have our endpoint security, all the devices. And then we want to protect our communication network as well. Right, firewall best practice. Okay, where we put this firewall in the boundary. Right, unwise to rely. Okay, you cannot totally rely on this. You have to implement host-based firewall as well. For example, you cannot rely totally on firewall. Right? Deny all traffic by default. Okay, ensure this is whatever firewall by default all traffic. Then you have to selectively permit some services, right? Okay, so firewall. Okay, just remind. Okay, later I'll show. If we have time, then we will do some demonstration of this. Okay, benefit of zone policy firewall. If I put all this, not dependent on ACL. Later we'll see this. Yeah? Router secure posture is to block unless explicitly allowed. By default, configure, okay, all are blocked. But now you are configure, you need to allow, okay, I want to allow that, I want to allow this, I want to allow this, and so on. Policy are easy to read. If you use the concept of 3CPL, Cisco Common Sequential Policy Language, the policy, the way they write the policy is for us to easily read and understand. So one policy will affect any given traffic instead of needing multiple layers. Design. There's some possible design. You have redundant firewall like this. You may have LAN to internet, one router, and then they separate between these two zones. Or we can have firewall in public server. We have DMZ just now we say, host inside, outside, and then some server, DMZ concept. So there are several ways of how we can implement our firewall, and we can put them into different zones. different zone. We have operation inspect, drop, pass. The three things that we can consider. We have to inspect, we want to permit, or want. Okay, rule for traffic. Yeah, source interface member of zone. Okay, this one is okay. Later we will configure. Okay, I will. This is just imagine router. I will say okay. I will configure this part is the zone is inside, and then this is outside. Let's say we configure this simple zone base. Yeah, you configure inside, you configure outside. Yeah. Okay. Now this table just simply say that okay, are you configuring this interface is part of the zone? The meaning, are you configuring zone? Okay, in this example, this table say, okay, I don't configure zone, and then the source, let's say, imagine this is the source, and then going here. Okay, I don't configure zone, I don't configure zone here. And both end, we don't configure zone. Of course, impossible you have this yes here, or no, because of course, when you don't configure zone, okay, we don't configure this pair, and then there is no policy. Of course, it will be passed. It will pass, meaning the packet will be go through. The packet will go through here. Okay, it's simply as that. It's saying that. Yeah, say that okay. There's no policy. Then this is what happened as of now. Yeah, we don't configure any zone. Okay, we are saying that okay, whatever packet from inside can go outside. Okay, that's why the packet pass. Okay, one side is zone, the other side is no. So meaning you already configure inside, and then the rest you don't configure. By default, it will block the packet drop. Similarly here, the other side, no, yes, also will be drop. Okay, also that's why zone is very powerful. Once you configure the zone, become the interface become members of any zone, then by default it will block the traffic. That's why the statement, remember one of the slide just now. By default, when you configure that as a zone, then you will block the traffic, right? So these three settle, yeah? So I hope you understand. And then one of the zone is yes, private and private, it will pass because both are the same zone. Inside the same zone, we put it. So you can have this one, the router, you configure this inside, and then another interface here you also configure as inside zone, inside. By default they are exactly the same zone, even though they are in different interface, and they the rules say okay, they should be allowed, same zone will be allowed. Okay, one public, one private, and then now we start to see, now we configure this. Okay, there is no policy, there's no policy, means they are both the same. Okay, just pass, okay, by default. Okay, then one is private zone, the other one is public zone, so meaning different zone. So the zone pair exists, there's no, then meaning by default is drop. Okay, once we configure zone, meaning we want to see okay, what policy should we apply? Should we permit, pass, or should we drop, or should we inspect? Right? There's only three possible answers to it. Yeah? So private to public, so different zone. Okay, the policy exists. The zone pair exists, but there is no policy, then we consider the policy is to allow. Okay, if we different zone, and then of course this one must exist, and then the policy exists, then now we have to check. Okay? We have to check the policy. Okay. Okay, this is okay. Now there is a concept what called self zone. Self zone is basically the router. Okay, you may protect your network, but for the router, you want them to see okay whether the router is alive or not. So that's why the only things that you see is either pass or inspect. That's why you ping the interface of the router. You ping the interface. It's not the network. You are pinging the interface, for example. By default, they are pass. All are pass. You can ping from either from outside, from inside. By default, you pass them. If there is a policy, then only you will check the policy. Okay, this is what we call safe zone from members, from other members of the zone, for example, in this case. So So safe zone means the router IP, the router itself. Right? I'm talking about the address of the router. Right? Okay, configuring a zone page. Okay, I will come back hopefully after this. You create the zone, you create the class map, policy map, and then you identify, okay, what zone pair, and then assign the zone. Okay, look example, then I think you can clear. First, we create the zone. I create the zone name private, we create the zone name public. Okay? And then the second is basically to create what you call class map. Class map to match, to say, okay, IT, okay, it's difficult to follow, but when you do exercise later on, I hope these all things come clearly, because I'm going to show a demonstration after this. Okay, maybe I can quickly go class map tab and step, and then you have the policy type, inspect, drop or pass. Okay, inspect, for example, this case inspect mean it's like a stateful. If you allow go out, you want to the same packet you want to allow them to come back. This is what you mean inspect. Okay? Drop and pass, similar like permit or deny. Right? And then zone pair, you create the zone pair. Okay, I'll give example after this. Zone member, and then you apply that to the interface. To apply you create the zone pair, you create the security zone security, and then you apply that to interface. You want to say, okay, this interface is actually private, this interface is public. Okay, you create this. Okay, verify, show whatever show there. Okay, later you once you configure, then you can come back to the slide and then type the show. Okay. And summary finish here. I will quickly show you the interface I have. The topology that I have. Anyone have problem with running JVM? I think sometime you start and then this one red. You can see green. Green mean it works, because most what I call appliances, they need VM. They need VM to run. So I have added every time I added a new what I call new appliances. Today, this last week I added this Ubuntu Docker. You can play around with this Ubuntu Docker. So they run Ubuntu inside Docker. So they will you can install. In my case, I install FTP inside here. Okay, what I have done here. Okay, maybe I stop first. Okay, I start, and then I will show the console. Okay, before that, I want to show you this, just to demonstrate. Stop first, and then start. I want to start fresh. R2, so R1, console. Everyone can see my GNS3, Can see my screen, Can,
Yes.
Okay, yes. R2. So I just want to demonstrate this, this thing. You take note of this, because I cannot show my full window. Take note of this. Okay. Try to squeeze all my windows so that you can see, and I also can see what I'm doing here. Okay, this is the R2. I'm trying to use R2. I don't connect anything, just R2, just to demonstrate some SS list. Configure terminal, and then SS list. Okay, when I type this, am I configuring number or name SL? I type SS list. So I'm configuring name SL or number SL. Number SL. Okay, number SL. That's why you can see number, right? You can see number. Okay, If you run packet tracer, you won't see all this. I think you can only see this and this. IP access list, IP standard access list, and then you don't see this option. Extended range, you don't see this option. Extended, which one? This. I extend. I have to wear glass actually now. Getting very difficult to see. Extended, expanded range. Okay, this one. This is for standard. This is another range for extended. So meaning you can use any. Okay, let's say before we always see example of this. So I'm going to use this range. Yeah. For standard, I'm going to configure this. Okay, just to play with it. So meaning I'm configuring 1,300. 13. I think you cannot. I think you can configure this in what I call in packet tracer. Okay, I'm going to instead of just the example 19, so I'm going to use 1,300, still configuring the expanded range, using expanded range, but I'm still configuring what I call standard. Yeah, let's say similar to this one. Just that the only difference is I don't use this range, I'm using this range. Yeah, this range. So, but just the same thing, just that different range. Yeah. So we have permit or deny. So permit. So I just follow that 192, 168, 100.1. And then same thing, I type access list 1300. So meaning that we have to use the same, like name also we are under the same name. But since we use number, then we use this one, deny 10, 10, 10.0, so 000.255. Okay? So there's no other option, right? Except source address. Yeah, access list 1300, and then you want to permit 201. Let's say I just write whatever number actually 110.0, 0.0.0.255. I can type access list 1300, and then I want to permit. I can type host, yeah, just to show you the option we have host. Okay, I can type 172.22.1.1. Right. Okay. Type host also, the iOS intelligent enough to know that it's actually because you enter a complete address, meaning it's host address. Okay, you can type show access list to show access list. You can see here. Okay, things that I want to highlight here. You can see the number here. Okay, I remember when I first learned ACL, I believe this was maybe 10, 15, more than 15 years, 10, 15 years ago, more than. When we study ACL, okay, the sequence is very important. Sequence. Nowadays, there are some, I'm not sure whether they're all, but some, they automatically, iOS will detect that, okay, there is particular host, it must be very specific. Okay? So it will come first. It will be sorted according to this, even though you enter, just now you see I enter this first, the second one, and then the third one, right, and then the fourth one. Okay? But then the router will sort this. It will start with the host. Everything, the specific host will be put in the list first, yeah, and then only more general like this one. Okay, more general. Because I can, okay, I can add on to this. Okay, let's say now I want to add, to edit. That's why I put here notice here to edit. So how am I supposed to edit? IP, I can type IP access list. I have to type the number. Okay. Sorry, I have to choose either standard or extended. Standard 1300. Okay, now I want to add, let's say I want to put 50, yeah, number 50. I say, okay, there's no number 50. 50, permit. I can choose host if I want, but then the what we call the iOS intelligent enough to know that I'm actually entering host even though I don't put host. So I can type, let's say now 10.10.10 dot, let's say 1. Okay. So this one deny. Okay. I say I'm denying all this, but I want to permit all this, only this particular. Okay, this is now, see the rules here. I want to demonstrate you, okay, the example here to say that, okay, you cannot give more than, the sequence number 20 is already covered that particular this one. Yeah, that's what, for this particular example, they said, okay, they know that you are, you already configured this, and then you basically you are saying deny, but now you want to permit only what I call that this particular host. Yeah, so you have to put that before this 20. So I can use, instead of 50, I will say, I have to say maybe I will put maybe 15, then only it allow. Yeah? So do show access list. Okay, now we can see that because the iOS will want to sort according to the to this sequence, meaning first we will put all the dedicated specific, for example, host address, and then only the general address like this. Okay, that is one way how we can you configure. Yeah, you configure and then you can edit them. For example, okay, I say I don't want number 15. And you show ICSD. Okay, now I say I don't want no 15. Okay, I can go back now, do show access list. You see now I remove the 15. Okay, you can see the range. You know that, okay, we can put 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 11, 12, and so on, right? So this is how we can configure the SCL, right? This is one example. Okay, now I'll stop this. Okay, I will run this router. Okay, now I want to open this. Yeah, I will show you later what I want to configure. This one. Let's see. Okay, I want to configure this. Okay, I want to configure extended ACL. Right? Okay, I have this server, FTP server. Start. It will get the address automatically from the DHCP server. I put my router 1 as my DHCP server. You can see this R1. I configured this as my DHCP server already. This one. Yeah. You learn this in CCNA, and then I create the network, the DHCP network. Both for both end, 111 and 112 from this side, and then from this side. Okay, so all these hosts will get the address from the server. Okay. I already configured this. Edit. So I open this. Okay. Open this. Uncomment this. Once it start, we'll try to find the server. Right. Okay, now I start this as well. Telnet and HCC. Okay, just for demonstration, maybe you can install Telnet server or HCC server here. Yeah, so that you can test whatever ACL that you configure to see whether you want to allow Telnet, you want to allow HCC, you want to block Telnet, HCC, and so on. So this is just for demonstration, for testing. You want to play around with ACL. Okay, I have my Ubuntu Docker here. Same thing. I already configured, double check. Okay, I already opened this. It will get the IP address from this router because this is my DHCP server. And then I have my web term here running. I will go to the console as well. Later I will show you my. Okay, from my R1, now I think, okay, I close the R2. I close my R2, already finished with this demonstration. Okay, I have R1, and then I want to FTP. Okay, FTP to this. So FTP to this GNS3, password, root, and GNS3. So I will go to my Ubuntu here. I'll open already. Oh, not yet. Okay, I'll open my Ubuntu console. Okay. I can FTP okay, sorry, before that we need to find, okay, what address all this I for because this DHCP running DHCP, so we have to find the address. Console telnet, and okay, we have that already. FTP server I if config, so the address is 101. So maybe I can quickly write here 112.101, and then for the web server, if config 112.102, automatically get the address from the DHCP server 112.112.102. Okay, and I can check my telnet interface as well. Telnet interface to show IP interface brief. Oh, sorry, not this one. Okay, sorry. So IP interface brief. Actually, I already get this. So ERIEF. I already have this address. Yeah. So 103. 112.103. So I have 112.103. So I can, from Ubuntu here, from my Ubuntu machine, I can now 192.168.112.101. Okay. Oops, sorry. It's missing. Ubuntu Docker. See, I already installed. I think I restart and it's missing. Wow. I cannot demo now. Anyway, you can do this. Yeah, later you can. I need to. Why is it not working? It's not persistent. Yeah, actually, I did it last night, if I'm mistaken. Okay. Anyway, maybe we can try SSH. SSH. Okay, it's not working. Strange. Okay. SSH. Okay, I'll try SSH. SSH. I cannot try FTP. Actually, I want to demo FTP. Very sad. SSH 192. Okay, later maybe if I cannot, I don't think I can make it today. I will try to demo during our tutorial. Just the beginning, I demonstrate, and then after that we can further see our what I call SS list. Yeah, we can play around with our SS list. SSH 192.168.112 and 103. Okay. Oh, sorry. SSH. I admin. I mean, if I'm mistaken. I hope my configuration I save it. Unable to negotiate with it. I found one issue here. I haven't find why what happened, but the particular SSH that I installed, I need to, because they say here, if you notice, negotiate is found, they offer Diffie-Hellman. So it seems that the server is running Diffie-Hellman group 1 char, but my current SSH is not running this. So one way around it actually to use this particular command. So I already find the answer to this. So I can use this to enforce to use this particular Diffie-Hellman group 1. So hopefully it's still working. Oops. So copy, show, copy. Okay, so 10, sorry, this is 103. Sorry, 103 because now the address change. Okay, I copy again. The address change. Are you sure? Yes. Oh, actually, I used the wrong, but you will find the what I call the same issue just now. So admin. So I can now go inside my router here. I can do the same thing with telnet. Can go back to this one, telnet, exit. Now I'm going to telnet. Exit. Oh, this is telnet. Sorry. Okay, here. Sorry. Exit. Okay, I'm going to exit. Telnet 192.168.112.103. Admin. Now I'm inside the inside this server. Okay, we can implement. Okay, I'm going to implement this. Zone. Where is it? Okay, this one. IPSS list. This one, yeah. And then we can apply. We will apply that inside our. Okay, take note of this. Because I'm going to put aside this one, IPSS list. So go back to my router number 1. Okay, I will configure terminal IPSS list extended and then permit client protocol. Permit TCP from any source to any destination equal telnet. Okay. Permit TCP from any source, any destination equal FTP. Permit TCP any equal. Okay, there's no SSH keyword. Somehow there's no, yeah. So if you check here, there is no SSH. No SSH. So you can type. If not, then you can use the protocol number. So we have do show SS list. So I have this SS list. Config extended SS list, name SS list. We call it permit client protocol. Permit client protocol. So this is the first step. Okay, what is the next step? What is the next step? You need to apply the SSL interface FA01. Where is 01? FA00. Okay, very important to apply on the correct interface. Interface FA00. Okay, now I want to say coming in, right? The packet is to come in to this one. I want to allow them to pass, right? If you put here, meaning you want to allow people from here to go here, not the other way around. Yeah. Now I want to allow people from this side. I assume, okay, I want to allow those hosts from here to access FTP, SSH, and also FTP, SSH, and also letter telnet. Yeah? Telnet, SSH, and FTP. You want to allow them to pass here. So meaning, if I'm the router 1, I'm expecting packet to come in. So I'm going to FA00. Then I will configure interface FA00, I will configure IP access group, permit client protocol, and then I have to tell, okay, inbound to my network, right? So you will allow this, yeah? Okay. The rest of the packet, for example, I can test with my webterm now to access my web server. Okay, I'll show you this web server interface. Application Firefox, right? Application Mozilla Firefox. Okay, I think I need to restart again. Sorry, yeah. It's not working now. My term. I left them and then they sleep, and then I cannot go back to my console. To open back. Hopefully it works. Now it's not working. Exit first. Exit. Yes, exit. Exit first everything. Okay, I try again, see whether I can this time. Stop. Okay, make sure you sign your attendant. The password is FSKTM. Okay, start. I will go to console. Okay. Now everything is not working. Okay. Okay, what I've done just now, actually I cannot demonstrate this. Hopefully Wednesday I will try to look at. I think I have to restart back my what I call my server, or maybe I will just open a new one. Yeah. Okay. Let me try it again one more time. I remove this, and then I will add my web term again. New web term. And then I will put back the interface. Okay, and then I will edit the address so that it will get the address automatically from the DHCP. Auto efface ATS0. I will save this. Double check. Edit config. Okay. Save. I will start. Hopefully it works. Okay, now okay. So now I can. Now it's working. I just want to demonstrate. Okay, you can. I already show you this. I can go to the internet because I put this NAT cloud, meaning it will share the bridge into my internet network and then go outside. So I can go to my. I can go to whatever. Yeah. Maybe. Oh, I don't know. Now it's not. Everything is not working. Yeah. So okay, never mind. Okay. Supposed to be able to do it. 192.168.112.102. 102, 112, 102. Let me double check. 192.168. Webterm. console stocks. Okay, this one also not working. Ah, strange. Okay, I will have to solve this. Okay, what I want to demonstrate just now, I want to show you, okay, I can FTP, I can SSH, I can Telnet, because I configure that 3 things. All these things actually working. Sorry, I don't know why now it's not, everything's not working. I think I have to restart again all my GNS3. All this will work. I can FTP, I can Telnet, I can SSH. The only problem is actually with FTP. You can log in, but then you cannot, for example, I cannot list, I cannot type LS. Because you know FTP, they have 2 different ports. They use 2 different ports. One is control port, the other one is data port. 20 and 21. When we put FTP, we are saying that we want to allow control port. Then we don't allow data port. So I want to demonstrate before. Okay, before SAL we can do that. Once we SAL we can log in, but we cannot send signal DIR, for example, or LS to the FTP server, because by default it is blocked. Yeah, this is the problem with SEL, normal SEL. You need to enable now the data portion as well with FTP. That's why you have to allow both FTP for control and also FTP for data. Yeah, there are 2. If I'm not mistaken, you can see the 2. Yeah, let me double check this one. There are 2 SEL. You can is it SS list? Okay, I try 100 permit any permit TCP any and then equal. There are 2 FTP. See, okay, there are 2 FTP. See here, you need to allow both of them, FTP data and FTP FTP control. Yeah, so this is data connection. This is another one is FTP control. So you will face problem. That's why we, if you notice, when people configure FTP, they will configure both. Okay, that's why I want to demonstrate just now. But unfortunately, I cannot now because somehow my guess, I already installed FTP here, but it's not working now. I cannot see why. I cannot. Just don't understand why it's not working now. I have to reinstall again. That's it. Ubuntu FTP. It's not working. My internet also not working, so I cannot ping it. Oh, I think because sorry, I'll just quickly try to remove the maybe because I put the SEL already and it's not working. So I remove this interface FA00 is my interface FA00 FA00 interface FA00 I access group. Okay, 00 no in. Okay, I remove this. Okay, I think maybe that was the reason why I cannot go to the internet just now. Okay. All right. I want to demonstrate to you. Okay, now this one can. Once I apply ACL, I cannot go because I only allow FTP, I only allow SSH, I only allow Telnet. I don't allow HTTP, right? So you need to allow them, then only you can configure. That's why once just now, actually it was not the problem of this, but actually I forgot that I already applied the ACL. Okay, now I can go to the web. Okay? Using this web term, I can go to this web server. Right? Okay, now you can play with ACL. Okay, I want to block that, I want to allow that, and so on. Okay, Okay, for Ubuntu just now, let me go back to this one. Ubuntu, my Ubuntu. Okay, now I can go to the internet. I can apt get FTP. I'm able to locate FTP. I can't remember how I. Yeah, I do it once. I forgot already now. Okay, never mind. If I'm not mistaken, this is how I configure FTP just now before. FTP. I'm not good in this one. Okay, never mind. I will demonstrate again maybe by in Wednesday, right? Okay, then the third one is actually the Zune base. The Zune base. Okay, I give all the PC. See all this PC, all the PC. Okay, I will start. Start all. I will start all. PC1, PC2, PC3, PC4, all with the different network addresses. Okay. PC1, PC2, PC3, PC4. And then I already configured the router with the address, like this one. Okay, the first step of configuring Zune is basically you will type this Zune security inside, Zune security outside, Zune security. Okay, before I configure this, okay, we can go to our PC console. Okay, so IP. Okay, I can ping other PC as well. This is PC1. So I try to ping PC2. Okay, I can ping another PC as well. Okay, I can ping PC4 as well. Okay, I can ping PC4. So all I can ping. But now I will apply Zune. Yeah, remember this is the first one. You create Zune. You create Zune. So I will create these 3 Zune. Okay, inside this router 1. This is router 3. Sorry, router 3. Router 3. Okay, open router 3. Console to router 3. Okay. Terminal. So I can create this 3 Zune. Right? Okay, and show run. I will create already 3 Zune. This is now creating. I only create Zune. Okay, but now I want to apply that to Zune, inside. So I'll go to interface FA00. Go back to my interface FA00. FA00. Then I will create this Zune. Use the interface FA00 as this Zune. So I copy this. Go back to my router 3. Okay, configure terminal. I'll go into the interface and then become Zune. So automatically now we see what will happen. You see, I will ping. See, it's not allow now. Straight away it doesn't allow. Remember the rule. Once this is become a member of a Zune, the rest not a member of Zune, it will automatically block. Right? So I will configure this. Okay, now I try to ping PC2. PC2 is 20.10. So currently shouldn't be allowed. Shouldn't be allowed. Okay, 20.10. I'm configuring PC. I'm pinging PC1 to PC2. It shouldn't be allowed. Okay? So I will change now. This network become inside network, meaning same Zune. Okay? Configure that as a same Zune. Router 3, and then I will configure this Zune of inside as well, right? So configure that, configure terminal, the interface, and then Zune security inside, and then go back to my PC1. So now I should be able to ping my PC2 because they are in the same Zune, right? See, now they are in the same Zune. So that is the concept. Now you create Zune, automatically the security enforce you cannot go outside by default. Yeah? Then only now you have to start to apply the policy and so on. So I already have played around with this, following the syntax inside our slide just now, and then create the zone, the rest for the zone, and then we create the class map, and then we say, okay, I want to mesh protocol, ICMP, meaning I just want to allow ICM pinging, right? Test with ping protocol, and then we create the class map, we call it ICMP, and then we create policy. This policy say any ICMP, this is the same one, ICMP, I will inspect, meaning I will allow the packet to come back, right? Inspect, remember when we have drop, pass, inspect. So inspect means stateful, meaning whatever going out, you want them to come back, right? And then you will create the zone pair inside source, which is the you are saying that, okay, there is an inside source and zone pair security name is this one, and then the source from the inside, the destination is from the outside, this one. Yeah? So we are creating pair between the inside and the outside, and then the policy say inside to outside policy, service policy type inspect, inside to outside policy, which is now applying this. Yeah? So we are applying the policy map. Inside the policy map, they will have classes. For example, okay, we want to match protocol ICMP, match protocol SNMP, and so on. We can apply, put all the match, the class map here. Even the ACL also we can configure inside here. Okay, and then only you can now ping from PC1 to the outside, from PC2 to the outside, but not from this PC1 to this DMZ yet. So you have to explicitly permit the protocol. Okay, by default it's denied, then only you have to permit them. Yeah, okay. So this is what I think we conclude our today present lecture. So any question? Okay, I'll show you again this. I show at the beginning. Okay, this is what, okay, I did some changes because I think some what I call assignment is worth to give more marks. Some I think I will reduce them. Okay, I already reduced them. So anyway, all this up to this are basically your 50% up to this, and then you have final packet tracer and then final online. Okay, don't worry much about this one. These are MCQ questions. These are MCQ, similar to your test, similar to your online test. Yeah, similar to your quiz, similar to your online test, MCQ. Okay. Any question about Gideon? For online test and packet, do we need to do both quiz? Okay, quiz is optional. I really advise you, after you read, before even you read, you start with your quiz. After you finish reading your chapter, you come back to your quiz, and then you do your online. Yeah. So quiz is not compulsory. I don't see where I can give you marks on that as well anymore. Test do we do with packet tracer only? Packet tracer. That's why I put here PT test. Both are PT test. GNS3 only for submission. For the 4th April deadline, just for the exam, right? Which one? 4th exam, which one? Can we retake the assessment? Okay, I put the deadline. I already emailed for the first 1 and 2. The rest I haven't opened yet. So if you want to retake, you have to give me reason. That's why I already stated clearly in my email why I'm supposed to reopen your online. Okay, for you later you PM me or email me. Okay. Okay. I will put this submit screenshot by this. Actually, you already, I can't remember what date I asked you to do this, but actually you're supposed, everyone's supposed to submit already this. Okay, it's already overdue. Okay? For those who haven't create the account, you must create now. You must start from now. Okay, hack this site. Actually, the aim is for you to gain as much mark as possible. The last student, last semester, they managed to get 7,000 marks. So you try to aim to get as high as possible, because those who get the highest will get the 10%. So the rest will be relative to your friend. So meaning, if one student get 7,000, and then that become 10%, the rest will get based whatever, you know, relative to that 7,000. Okay, that is for the hack, only for the hack this site. Okay, am I answering your question? Okay, okay. That's why you try to beat your friend. If you so far, I think 7,000 is the highest. 7,000 something, I can't remember now. If you can get 8,000, maybe. Yeah. Okay, so no more question. So I will share this inside again next week. Maybe some other modification, I don't know. If you agree with this, no objection, then I will put this as what I call the milestone. I will follow every single one of these. Okay, for example, chapter 1 and 2, the final one will be this. If you fail to do by this, as I say, I'm not going to open again. So that's why this time I want to put everything clear. So every time when we start our lecture, I will show you this. Yeah. If you think that, okay, you need to make, instead of week 8, I think should be week 7 or week 6, then I will change this. Okay. Okay, guys. Okay, so I think that's all for today. Yeah. See you on Wednesday if there is no question. Okay. Don't forget to sign your attendance. Okay, guys. See you.
Thank you, Doctor.
Yeah.
Thank you, Doctor.
Thank you, Doctor. Thank you.
Thank you, Doctor.
Yeah.
Thank you, Doctor.